Okay, I just want to remind you again, my name is Ron Bannon. If you need to reach out to me, my name is Bannon. Whoops, sorry about that. Whoops, I did it again. My email address is Bannon, that's B as in boy, the at symbol, NNON.US. And again, if you reach out to me and have something constructive to say to improve the document, that's helpful. And certainly I'll try to get back to you if I can. If I'm overwhelmed, I won't be able to get back to you, by the way. Now, this problem over here, number 13, my claim about this one over here, number 13, it's a tough problem, all right? Now, I hope you realize that there's some simple things about it, but I am going to go to the whiteboard. So, certainly when I go to the whiteboard, hopefully you're not losing track of what I need to do, which is reread the problem. But the problem is going to disappear now, but hopefully you have a copy of this document and it's not disappearing. But I'm going to write down what I do know about the document. And let me put this over here, get rid of that. And let me write things down then. So, I know I have a 3-digit number. So a 3-digit number to me, fairly simple to do. It looks sort of like this over here, a 1-digit, 2-digit, 3-digit. And then, kind of understanding a 3-digit number. And again, to read it is to understand they said something about it. They said the digits of the 3-figure number are in geometric progression. So I'm going to say, well, if that's true, this is A, this is AR, and this is AR squared. I hope you realize if it's a number, and they're talking about integer, by the way, that these have to be integers. A must be an integer, A times R must be an integer, and A times R squared must be an integer. They must be integer, all right? So the question is, I wonder what the R is. I wonder what the A is. So I need to read it. And what do they say about it? They say this. They say the digits of a number of 3 figures are in geometric progression and their sum is 14. Let me write that down for you. A plus AR plus AR squared is 14. They said that. Okay, so let me read it again to you. The digits of a number of 3 figures are in geometric progression and their sum is 14. If 594 is subtracted from the number, so I got to write this down. If I subtract 594 from the number, what's the number going to be? 100A plus 10AR plus AR squared. What they claim is if I subtract 594 from the number, the digits will be reversed. What does that mean? 100 AR squared plus 10 AR plus A. All right, I got trouble. I got 2 equations, 2 unknowns, but I got some help over here. I know that AR squared are integers, right? I also know that this number here is bigger than that number over there by 594. Let me get my eraser out. I'll erase this over here. And again, I'm just working through the problem. I realize sometimes the key that's provided to you might confuse some students. Right. The first thing I'm going to do is I'm going to try to simplify the second equation. And I'm hoping it's going to be really simple to do. So one thing I notice is that, right from the get-go, that 10AR when subtracted from both sides, that disappears. The next thing I notice is if I subtract A from both sides, and if I subtract 100 AR squared from both sides, and if I added 594 to both sides, what would I get? Well, let's write this down. 99A minus 99 AR squared equals, let's say if I did that right, 100 minus 1 is 99. 1 minus 100 minus 99, it's 594. All right, let me pause for a moment, make sure I copy the right number down before I go further. Yeah, 594. What I'm going to do is divide maybe I shouldn't have said that. I'm going to divide 594 by 99. And looking at that, that goes in 6 times. So I'm going to say 6 times 99 is 594. It's easy to say something. What if it's true? Well, let's see. 540 and 54. Yeah, 594. Works beautifully. So what do you get over here? A minus A R squared is equal to 6. I am now going to highlight two things. This and this. And I'm going to work with those two now to try to figure out what A and R is. All right, so I'm looking at it and I'm wondering what to do. And what I'm going to do is I'm going to try a division. And I don't know if that division is going to work out too nice, but I'll write this down though. So I'm going to try a division problem now. So I'm going to try 14. I'm going to try to divide it by 6. So I'm taking this equation and dividing this one. And I'm hoping I get something pretty simple. And what's 14? Well, it's equal to A plus AR plus AR squared. By the way, this is different than the way I've done it in the key, by the way. Let's hope things work nicely, though. This is my first time trying this, and that's why I'm seeing it now. So I think I can do something with that. Did I write that right? A plus AR, AR squared, A minus AR squared. Yeah, I think I can handle it. So I'm kind of looking at it, and I'm going to reduce it, and that's 7/3, right? I'm going to divide top and bottom by A, and then I get 1 plus R squared. I'm reducing it, by the way, and 1 minus R squared. All right, this is good news, by the way. I'll tell you why it's good news. I'm getting a quadratic and one unknown. Let's write this down. 7 minus 7 R squared is equal to 3 plus 3R plus 3R squared. Let's see if I did that right. 7 times 1 is 7. 7 times minus R squared is minus 7R squared. 3 times 1 is 3. 3 times R is 3R. Yeah, it looks all right. Quadratic. Use zero product rule if I could. And let's see what I got over there. You can get 10R squared. And then you get plus 3R. And then you're going to get, let's see, minus 4, right? Let's see if I did that right. So 7 and 3 is 10. That's 10R squared. You get 3R, and then 3 minus 7 is minus 4. Good. Let's see if we can factor it. Oh, boy, that looks like a tough one, doesn't it? And let's take a look at that. Let's take a look. 2R, 5R. Oh, you know what? Let's use AC rule. I haven't done that in a while, right? So let's take a look at that. 10 times minus 4. That's going to be minus 40. I need to find two numbers that multiply to minus 40, but whose sum is going to be 3. Well, 4 and 10 wouldn't work, right? 8 and 5. Look at that. I'll write that down. 8 and 5. 8 and 5. And that would be minus 5. So let's write this down. 0, 10R squared minus 5R plus 8R minus 4. Don't despair. It's going to work out nicely. We get 5R, and this would be 2R minus 1. Factor out of 4, and that would be 2R minus 1. 0. Wow, this is going to get really crazy, isn't it? 2R minus 1, 5R plus 4. So I got R equals 1/2, and I got R equals minus, let's be careful about this, minus 4/5. Now the problem with a lot of students is they really forget what they've read, but they're so happy to get somewhere they put a box on it. But I got to be honest with you, this is not their answer. That isn't even their question. Then the question is, what was their question? Well, you know what? I got to go back up here, and I got to figure out A now. And then we'll talk about their question. So A minus AR squared, I'll write this on the side, is equal to 6. A minus AR squared equals, and someone says, why'd you choose that one? It's easier than the other one for me. That's why. That's the only reason why. Let's take a look at this. So let's do this first. What would you go here? A, I don't know what A is, minus, that would be what? A over 4. And that equals 6. I'm going to multiply both sides by 4. You would get 4A minus A equals 24. And over here, what would you get? You would get 3A equals 24, and A equals 8. By the way, I'm not saying that's the answer either. I'm just saying A is 8, R is that. I'm just looking, I'll go back and read it later. Now let's do this one over here. Let's not be confused about that. And what do you get over here? Let's write this down. A minus A times 16 25ths is equal to 6. I am going to multiply both sides by 25. Let's see, 25 times 6, 150. Don't despair yet. And 25A minus 16A, let's see what would they give you, 9A, right? And then A would be 150 over 9. Now, by the way, if you have some memory, I think you probably remember we had a 3-digit number. What would the 3-digit number look like this over here, wouldn't it? And what was the first digit? A. What was the second digit? AR. What was the third digit? AR squared. This is outrageous. There's no way it could be 150 over 9. So I'm left with this one over here. And so what I'm going to do is I want to kind of write it down. I want to see if it's good. So I've got these two things over here, and then we'll look at the question later. So what's A? 8. That's the first digit. What's the second digit going to be? Well, 1/2 of 8, which is 4. Wow, what's the third digit? It's going to be, let's see, 1/2 of 4, which is 2. So the number's 842. By the way, it's been a while since we did the problem. I want to go back and read it. And what is it going to be? Yeah, they got the number, 842, same number, all right? By the way, their method, my notes a little bit different. I was thinking an integer problem. Integers sometimes are hard to think through, but I did give a different narrative to the problem. Certainly either way, one day I'll do one day I'll do another. And I'm sure if a lot of people are reading these documents, I'm sure there's people that have even better ideas than I've done in either case. And that is so true about problem solving. And some people are remarkable in their ability to look at problems numerically. But again, we're really studying the concept of algebra, and this is really an algebraic approach to the problem. I realize the problem I've written down for number 13 is not necessarily algebraic in nature. Thank you.